So it says a particle is projected at 30 meter per second at 50 degree to the horizontal, and there is a wall 10 meter at a distance of 10 meter from the point of projection. So if the particle is projected from here at 50 degree, so the question is how high up the particle will strike the wall. So if the particle strikes here, what is this height? That's what the question is. So this is 10 meter far from the point of projection, and we have u as 30 meter per second, and the angle, initial angle, projection angle is 50 degree, the elevation. So we know that this is 10 meters away, so the distance that the particle goes is like this. At t seconds it will go like this. So this is the horizontal component of the velocity, which remains constant throughout. So u cos theta times t is r, and if r is 10, we know that how much later the particle will strike the ball. So how long will it take for the particle to reach up to the wall? So if we can find it from here, so 30 cos 50 times t, and that gives us t as 0.52 seconds. That's what we know. Now since we know that, we also know the vertical component of the velocity, because we know the velocity and the angle. So we can find the height using this equation, ut minus half gt square. This u will be, of course, u vertical component of the velocity, and that will give us the height, how far it goes. So t we know, so we can just use that. So 30 sine 50 degree times 0.52 minus, because this is ascending, the ball is ascending, so it is subject to deceleration, times 0.52 square. So 11.95 minus 1.32, we get 10.63 meters. That's what we get as the height. So this height is 10.63 meters. Now the second part of the question is, at what angle does it strike? So we need to know the angle. Now we know the horizontal velocity, we don't know the vertical velocity when it hits the ball. We need to know that it shouldn't be horizontal, it should be like that. So we can use this equation, v is equal to u minus gt, to find the vertical velocity at that point. So that will be uv will be eu 30 sine 50 degree minus 9.8 times 0.52. So that is 17.88 meter per second. That's what we get as the vertical component of the velocity. So tan theta will be the vertical component of the velocity divided by the horizontal component of the velocity. The horizontal component stays the same, which will be u cos 50 degree, 30 cos 50 degree basically, and this is 17.88. So 30 cos 650 degree will be 19.28 theta. I'm using theta again. Let's use another angle because I used theta earlier. So that will be tan inverse of this part, 17.88 over 19.28, and this is 43 degree. So that's the angle. But we need to we should check one thing, that whether the ball is still ascending or descending. So that we can do, if we want to find when the ball reaches its maximum height, we can do v is equal to u minus gt, and this is 0. That will be 30 sine 50 minus 9.8 over 2 t times t. T will be 30 sine 50 degree and 9.8 over. So that's 2.34 seconds, which is much bigger than 0.52. So we know that the ball is ascending. We should